this lesson, we'll adjust and generate a finite element mesh for the structure and define interactions between the bracket components. Now the model is ready for finite element mesh generation. Start the Generate FE Mesh command. Let me expand the toolbar to display the tool names. There isn't enough space. I'll shrink the other toolbars to free up some room. A system notification appears. This is not an error, but simply a recommendation. We'll keep the default settings and confirm mesh generation. A notification appears. The system informs us that contacts and joints should be defined between the parts. Our assembly consists of several components. Their interaction has not yet been defined. We'll do this later. We don't want the system to create contacts automatically, so click No. We've obtained a mesh that consists of 10 noded tetrahedrons and contains approximately 42,300 nodes. You can use this slider to inspect the mesh interior and evaluate the mesh quality. Let's return the slider to its original position. If you decide that the mesh needs adjustment, you can start the Generate FE Mesh command again and modify the mesh parameters. The mesh can be generated using absolute size values. In this case, you can specify the minimum and average element sizes. For example, I'd like at least 2 elements through the bracket thickness. I'll cancel the current command and start the Distance and Angle command. Let's use the search field to find it. Measure the bracket thickness. It's 6 mm. Let's return to mesh generation. I'll set the minimum element side length to 3, which is a half of the bracket thickness. For the middle length, I'll set 5. This allows the system to use larger elements where appropriate. Confirm. Click No. The new mesh contains significantly fewer nodes, approximately 12,400. As a result, the analysis will require fewer computational resources. Let's hide the mesh using the command from the context menu. The mesh cannot be edited directly. We cannot move individual nodes manually. Instead, we adjust the mesh parameters and evaluate the resulting mesh. Once we're satisfied with it, we can hide its graphical representation so that it doesn't obstruct the model. The mesh itself will still be used during calculations. Now we'll define contact interactions between the bodies. This can be done either manually or automatically. In both cases, start the contact command. Select the first object that will participate in the contact. In our case, it will be the plate. Then select its contact face. Activate the second body option in the tree. Select the bracket as the second body and then select its contact face. Select the contact type. Different contact types allow you to simulate different types of interaction between bodies. For example, a sliding contact allows bodies to slide relative to each other with or without friction. In our case, we'll use the glue contact. Confirm and stop the command. The new contact has appeared in the Context section of the tree. If you select it, the contact faces are highlighted in the graphics area. Let's delete this contact and try creating one automatically. Start the contact command again. Automatic contact creation is especially useful when your model contains many bodies. Click Auto Search. Select the newly created contact in the tree. Notice that some additional faces have been included in the contact definition. For a linear static analysis, however, this doesn't affect the results because those additional faces are not actually in contact with each other. Nevertheless, we can refine the contact definition. Click the extra faces on the bracket to remove them from the contact. Then switch to the second body and remove the unnecessary faces on the plate. Confirm. We've defined the boundary conditions, assigned the material, generated the finite element mesh, and created the necessary contacts. The model is ready for analysis.